Question 5. A particle rests on a smooth horizontal table between two vertical walls which are 35 metres apart. It is attached to the left-hand wall by means of a string of natural length 2 metres and elastic constant 7 newtons per metre, and to the right-hand wall by means of a string of natural length 3 metres and elastic constant 3 newtons per metre. We have to find the position of equilibrium, and the two positions where the resultant force on the particle would be 40 newtons. So if we want to find the equilibrium position at O, this means that the force to the left is going to equal the force to the right. Now we don't know the distance from O to A, so we'll let that be x. This means the remaining distance has to be 35 minus x. So the force to the left is going to equal the force to the right. So using Hooke's law, K on L minus L0 to the left is going to equal K on L minus L0 to the right. Now the K value for the elastic on the left was 7, and from the diagram the length of the elastic on the left is x, and from that we have to subtract its natural length, which is 2. This is going to equal, on the right hand side, the K value is 3. The length of the elastic on the right is 35 minus x, and from that we have to subtract its natural length, which is 3. So multiplying out, you get 7x minus 14 equals 96 minus 3x. Bringing all the x's to one side, you get 10x. Bringing the constants to the right, you get 110. So this means the equilibrium position is 11 meters from the left-hand wall. Now if we want to find the two positions where the resultant force on the particle would be 40 newtons, this means that the particle could be placed such that the force to the right is 40 newtons bigger than the force to the left. Alternatively, it could be placed such that the force to the left is 40 newtons bigger than the force to the right. So we first of all, if we want to find out one possible position, the distance from the left hand wall to the particle, let that be x, and that means then the remaining distance is 35 minus x. So first of all, if we let F be the force to the right minus the force to the left, and we do know that resultant force is 40. So 40 is going to be K on L minus L0 to the right minus K on L minus L0 to the left. So the K value on the right was 3. The length of the elastic on the right is 35 minus x, and its natural length is 3. And then minus the K value on the left is 7. The length of the elastic on the left is x, and we just subtract its natural length, which is 2. So on the right hand side, you get 96 minus 3x minus 7x plus 14. And the x's on the right add to give minus 10x. So if you bring that over to the left, you get a plus 10x, and then all the constants add to give 70. So this means x would be 7 meters from the left-hand wall. Now, alternatively, another possible position would be when the force to the left minus the force to the right is 40. So here, 40 is going to be K on L minus L0 to the left minus K on L minus L0 to the right. And the K value to the left is 7. The length of the elastic on the left is x minus its natural length, which is 2. And then if we subtract the K value on the right is 3. The length of the elastic on the right is 35 minus x. And again, if we subtract its natural length, which is 3. So this means 40 equals 7x minus 14 minus 96 plus 3x. Bringing all the x's to the right, you get 10x. All the constants to the left, you get 150. And this then means x would be 15 meters from the left-hand wall.